Hello and welcome back to another SAT video.
AP3.
In today's video, we'll be going over SAT math questions, more specifically right triangles. We're doing easy, medium, and hard questions. So without further ado, let's get started. The lengths of the legs of a right triangle are shown. Which of the following is the closest length to the triangle's hypotenuse? Okay, so what are we looking for? Is this line right over here? Now you might be asking, well, how can we solve that? Well, we're looking for the hypotenuse, and the hypotenuse is always the longest side or the diagonal side in a right triangle, which is what we're looking for, right? So a formula that you guys probably know already is called Pythagorean theorem, which is a squared plus b squared equals c squared. Now what this gives me is whatever length in the right triangle. So in this case, we're looking for the hypotenuse, and the hypotenuse is always c. So h for hypotenuse always equals c. C is always going to be the diagonal line or the longest side in a right triangle. And a squared plus b squared is always the two legs, in this case 7 and 3. So what we can do is do 7 squared plus 3 squared equals c squared to figure out my value of the hypotenuse, or c, or h, sorry, it's hypotenuse. So we do that math, that equals 49 plus 9, and that gives me roughly c squared, which will give me 59, or 58, sorry, equals c squared, which will equal c equals the square root of 58. So what I want to do is look at my answer choices and see which one correlates, right? It can't be 20 because the square root of 20 equals 400, square root of 5 equals 25, sorry, and the square root of 3.2 roughly gives me 9 point something. Therefore, my answer is going to have to be C, because that is the closest length to the hypotenuse. Let's do another question. In the triangle shown, what is the length of tangent x? So what is tangent and what can we do with that? Well, I'm given two lengths, right? 7 and 26. And for this question, we don't need the hypotenuse. So that's kind of irrelevant, right? So if you probably, already know, or if you don't know, that's completely okay. There is a term or like abbreviation called SOHCAHTOA, right? And OA, right? And basically, SOHCAHTOA is just abbreviation going over sine, cosine, and tangent rules that are all revolved on the SAT. What do I mean by that? So as we went over the other question, it had an hypotenuse, and the other two legs, depending how you look at it, is the adjacent or the opposite. So what does that mean in this case? We're looking for tangent. So we're going to use TOA. And TOA can be tangent equals opposite over adjacent. And opposite is the opposite length that's corresponding to the angle measure, and adjacent, or A, is the length closest to it. In this case, when we look at x, we can see the opposite length is 26, so 26 is going to have to be on top, and adjacent, like we said, is the length closest to x, or the close to x. In this case, it's going to be 7. Therefore, tangent of x equals 26 divided by 7. Therefore, my answer is going to be C. Let's do another question. For the right triangle shown, A equals 4 and B equals 5, which expression represents the value of C? It's just a question I did the first question that we did, which is A squared plus B squared equals C squared. And all we have to do for these type of questions is just plug in A and B and figure out what is my expression or value of C. So as we can see, A, B, and C are all given, and we're given that A equals 4 and B equals 5. So we can write A equals 4 and B equals 5, and C is what we're looking for. So let's plug A and B in the Pythagorean theorem. So if we do that, we're going to get 4 squared plus 5 squared equals C squared, and we're looking for C, remember. And if we multiply or just square everything, we're going to get 16 plus 25 equals C squared. And all I have to do is use the square root on both sides, and that's going to give me C equals the square root of 16 plus 25, or we can rewrite that as 4 squared plus 5 squared. And our answer is going to be D. And I rewrote that because that's what they did in these type of questions. For these type of questions, you need to understand that most of the time, they're not going to give you the answer in front of your face. So you have to figure out how to rewrite it in some questions like these. Okay, let's do medium questions now. Triangle FGH is similar to triangle JKL, where angle F corresponds to angle J, and angles J and K are right angles. If sine of F equals 318 divided by 17, what is the value of sine of J? Okay, there's an important keyword in these type of questions. We're given that triangle FGH is similar to triangle JKL. So what does similar mean? Well, similar basically means that all the angles that correspond to each other will equal each other, as it gives here when it says F is with J and G is with K, right? So what that basically means is that all the angles are equal. So in similar triangles, angles are equal. They're equal to like the angle that's corresponding to, like F and J are going to be equal and G and K are going to be equal. And the lengths are proportional. What do I mean by that? Well, let's look at two triangles, for example, right? Assume that they all have the same degree. And I have, let's say, 1, 2, 3. Well, proportional basically means is that they have like the same ratio or like the same value, but just a little bit more. What do I mean? Well, let's say I do 8, 24, and 4, right? If I divide the right triangle by 4, I'm again going to get 2, 3, and 1. You see what I mean? They're equivalent, but one of them is going to be a bigger number. So what similar triangles are again? The angles are equal, but the lengths are proportional, meaning that one triangle is going to be smaller and one's going to be bigger, but the ratio of each is going to be the same. So in this case, we're trying to look for the sine of 308 divided by 317 and look for the value of sine of J. Remember how I said that the angles correspond to each other? That's why it's very important to read every single question little by little, because you don't need to do math for this type of question. What do I mean by that? Well, if we say that angle F corresponds to the angle J, that means whatever F is, it's going to equal J. So if I do sine of, let's say sine of F and sine of J, we're going to get the same thing. I do cosine or cosine of F and J, we're going to get the same thing. Therefore, the value of sine J is also going to be 308 divided by 17. Therefore, my answer is going to be B. And I showed a similar triangle so you guys understand, what that is and how can you use it for different types of questions that pop up on the SAT, because reviewing a concept over and over and over again only helps you. Here's another question. A right triangle has the legs with the lengths of 28 centimeters and 20 centimeters. What is the length of the triangle's hypotenuse in centimeters? Okay, so I'm given a right triangle, right? And we're looking for the hypotenuse. Therefore, we can determine that we're looking for this length over here, the longest one, and we can say that the other two legs are 28 and 20. And we're looking for it in centimeters, basically the same measurement as the other two legs. So we have to use Pythagorean theorem again, so let's plug it in. So we're going to do 28 squared plus 20 squared equals c squared, which is going to give you roughly the amount of 1,184 for the amount of c squared. C squared equals 1,884. So what can we do with that now? We're looking for the hypotenuse. And remember, c is the hypotenuse because c is by itself. So we can do c squared equals 1,184 and then look for c. Well, what can we do? We can do square root on both sides. And we're going to get c equals the square root of 1,184. Therefore, we can cross out d because d needs the square root for it to be correct. Because it's not its square root, that's assuming that the answer C, that means the answer C is 1,844. However, we're given that C equals the square root of 1,844. Therefore, D is incorrect. So now what we want to do is figure out what can we do with the 1,184. Well, in these types of questions, what I like to do is figure out, can it be squared out? What do I mean by that exactly? So let's say, for example, I have the square root of 8. Right? I can rewrite that as the square root of 4 multiplied by 2. And as we can see, 4 is indeed a square root. So I can move it out of the square root and write the new expression as 2 to the square root of 2 because the square root of 4 is 2, so I can put 2 in the outside of the square root. So let's do the same thing for this type of question. Figure out what value of 1,844 can be subbed out. Let's try 16, right? If I do 1,184 divided by 16, I get the number 74. And 16 is indeed a square root because it could be square rooted by 4. Therefore, C equals square root of 74 multiplied by 16. The 16 is going to get squared out, which is going to be 4. So I'm going to have the 4 square root of 74, and my answer is going to be B. I picked this question for you guys to understand how to work these type of questions. I consider you to do even more math after you figure out what C is, because in this type of question, you probably put D because you're given 1,844, but that's C squared. You gotta look for C, which is why you gotta do a little bit more math, and this is why I picked this question to show you guys what to do to look for the square root of numbers that can be simplified. Okay, let's do another question. In triangle ABC above, what is the length of AD? So we're looking for a length right over here, right? We don't know it. Let's digest the information given to figure out what can I assume. So we're given a right triangle of DBC, and I'm given that C equals 60, BC equals 12, and I'm given that DB is like in the center, right? So what can I assume? And we're also given that B equals 30. Well, let's look at the triangle, right? Let's just ignore this one and just look on the right side, sorry. I'm also given that D equals 90, sorry. So let's add all the numbers. So if I have 90 plus 60, that's going to give me 150. 150 plus 30 equals 180. Therefore, I can say, right, that is, it equals 180. But let's look at the left triangle now, right? It's technically the same thing because D is still the right triangle and B still equals 30. Therefore, A also equals 60. So where am I going with this, right? If A equals 60 and C equals 60, right? And if we look at B, we can assume that B on the right side equals 30 as well because we just did the math to figure out that DBC equals 180 degrees because C equals 60 and D equals 90, which equals 150. And the missing value is going to be 30, I can say that B in the whole triangle of ABC, right, equals 180 degrees, and B has an angle measure of 60. Therefore, the triangle of ABC, so let me redraw it over here, ABC, they all have the number 60 on every single side. Therefore, I can assume that this is an equilateral triangle. And this is important because in an equilateral triangle, all the angles equal the same and all the lengths equal the same. Therefore, BC equals 12, AC equals 12, and AB equals 12 as well. So to look for AD, all I have to do is figure out that because D is in the middle of AC, I can assume that AD is going to equal half of AC because AC equals 12 and we draw a line in the bottom. Therefore, all I have to do is do 12 divided by 2, which gives me 6, and my answer is going to be B. And the answer is B because, like we said, because we assume it's an equilateral triangle, all the angles and lengths equal the same. So ABC, all of them is equal 60, and all the lengths like AB, BC, and AC all equal 12. And we draw a line in the middle between B and D. D's in the bottom, and D is like in the middle or the midpoint between AC. And because D's in the middle, we can cut the lengths of AC to AB, AD, and DC. So we do 12 divided by 2, and it equals 6. Therefore, AD and DC equals 6. So my answer is B. Let's do another question. In the right triangle shown above, what is the length of PQ? Let me erase everything here really quickly. So we're given some few things, right? I'm given that R has an angle measure of 30, QR has a length of 8, and QP has the length that we're trying to look for, right? So because we have an hypotenuse, we're not going to use TOA or tangent in this question. We're either going to use sine equals opposite over hypotenuse, or cosine equals adjacent over hypotenuse. You can remember that using, like I said before, SOHCAHTOA. And for this, we're not going to use it for this type of question, but tangent equals opposite over adjacent. And remember, just for reference, the hypotenuse is always the longest side, or the diagonal side, as I like to say. The hypotenuse is the length that's across the given angle measure, and adjacent is the side that's close to the angle measure, right? So you'll see what I mean, right? If we look at the opposite, right, or if we look at QP, right, it's across the angle measure given. If we look at 30, QP is across. Therefore, I can say that QP is the opposite of of R. Therefore, I'm going to use sine equals opposite over hypotenuse to figure out my value of QP. And I'm not going to use cosine because if we were looking for the adjacent, that would be PR, because if you look over here, it's the closest length to 30, which is the angle measure given. Therefore, it wouldn't be PR, it's going to be QP for this type of question. Therefore, I'm going to plug in the information given to figure out PQ. So what I can say is that sine of 30 equals QP divided by 8. So what I can do now is plug this into my calculator to figure out what is the values that I'm looking for, right? So if I were to plug in sine of 30 to my calculator, right, because you can use your calculator in the actual test, you're going to get the values of 0.5. So sine of 30 equals 0.5, which equals QP divided by 8. And it's important to know, right, your unit circle if you're in calculus, or even if you're taking algebra 2 or taking the SAT in general, because if you know your unit circle really well, you can do mentally sine of 30, cosine 45 easily if you understand it, right? But if you don't understand it, that's completely okay, because you can just plug in the same numbers in your calculator and figure out the value. In this case, it equals 0.5. So all I have to do is multiply 8 on both sides, and I'm going to get my answer. So if I multiply 8 on both sides, that's going to give me QP equals 8 multiplied by 0.5, and that's going to give you 4. So QP equals 4. And remember, we would use cosine if it was adjacent. But in this case, because QP is the length that's across the given angle measure of 30, we're going to use sine, and that's going to give us the value of QP equaling 4. Here's another question. Right triangle ABC is shown. What is the value of tangent of A? As we can see, we don't have A. We're given C and B. We're given that B equals 30. And because C is a right triangle, C equals 90. But how can I look for A? Well, let's understand that in the full triangle, right, as we know, there is an angle measure of 180 degrees in total. Therefore, what I can do 180 minus 30 plus 90 to figure out my value of A, which that's going to give me 180 minus 120, which equals 60, which equals A. So tangent of A is going to equal tangent of 60. But what can I do to figure out my values? Well, since we have the angle measures of 60, 90, and 30, this triangle is a 60, 30, 90 right triangle, right? But why am I saying it like that, right? Well, it's important because this type of triangle is given in the SAT reference sheet. So let's look at that really quickly. If I go to my SAT reference sheet, I can see that I have two right triangles right over here. And if we look at the 30, 60, 90 triangle, I can see that 54 corresponds to 2x. So 54 equals 2x. And in the bottom one, in this case, it's going to be x. And then the AC is going to be the square root of x3. So how can I look for my x value? Well, 54 equals 2x. If I divide 2, I'm going to get x equals 27. Therefore, CB equals 27, and AC equals 27 to the square root of 3. So what I can do now with the information given is figure out how to plug it into tangent of 60, and I'm going to get my answer. Remember, tangent of any number is going to be opposite over adjacent. And as we can see, the opposite length of A is going to be CB. So we're going to write equals 27. And then the adjacent is going to be AC. And AC is going to be 27 to the square root of 3. Therefore, tangent of 60 equals 27 divided by 27 to the square root of 3, which equals 1 to the square root of 3. Therefore, my answer is going to be B. And you don't need to remember how a 30, 60, 90 triangle is because it's in the SAT reference sheet. But if you know how to use it or you know how to like manipulate all the numbers, this makes the question a little bit more easier and you save a lot more time as well. Okay, let's do another question. The perimeter of an equilateral triangle is 624 centimeters. The height of the triangle is k to the square root of 3, where k is a constant. What is the value of k? So I'm given an equilateral triangle, right? And like we said before, in an equilateral triangle, all the angle measures equal the same. So I'm going to have 60, 60, and 60 angle measure. And every length is equaling the same as well. But in this type of question, we don't want to do that. We're given that the height has the height of the equilateral has the height of k to the square root of 3. So right over here, I'm gonna have k to the square root of 3, and we gotta look for k, right? So let's remember we did this in another question, and we did it just the question before as well. So if we look at the questions given, I can see that because the height's in the middle, I can assume that we're gonna have a 30, 60, 90 triangle. Because if it's cut in the middle, the angle measure and the length of the bottom length is to be cut in half. Therefore, I'm going to have 30 here, right, if we make the line. And I'm going to have 30 here on the left side too. So what can I assume? Well, let's look at our reference sheet again, right? I'm given k to the square root of 3. And I'm also given x and 2x. So what can I do now? So I'm given that it has a perimeter of 624. Therefore, right, all the lengths are going to equal 624 if we add them up all together. But how can I look for that? Well, to look for that, all I have to do is do 624 divided by 3, and I'm going to get an answer. So if I do 624 divided by 3, if you plug that into a calculator, we're going to get 208. Therefore, every single side is going to equal 208. So let's do that really quickly. 208, 208. And 208. But this side's a little bit different because remember I said when we make a line, the lengths of the bottom one's gonna be split in half. Therefore, I'm gonna have on one side 104 and the other side 104. So if we look at these type of question, I can see that we're gonna have 2x, x, and x to the square root of 3. And in this case, in this triangle, x equals 104. Right, and we're looking for k, and because k corresponds to x, I can say that k equals 104, and that's going to be our answer. Because if we look over here again in our reference sheet, I can see that x corresponds to all three sides, right? So 2x, x, and x squared root of 3, and because k is just x, that's why it equals 104. And this is why it's important to understand equilateral triangles and just triangles overall, because they have a lot of rules that are not given in the SAT reference sheet for the most part anyway. Okay, let's do another question. Triangle ABC is similar to triangle DEF, where A corresponds to D, C corresponds to F, and angle C and F are right triangles. If tangent A equals 50 divided by 7, what is the value of tangent of E? Okay, so we can say that because A corresponds to D, so A equals D, C equals F, I can say that B is going to equal E as well, because regardless of what ADCF equal, both of those angles combined are going to give me an angle, and because B and E correspond to the angles given, it's going to give me the same amount. So let's say, for example, if A, let's say it's 60, D equals 60, right? And if I say, let's say C and F equal 30, right, that's going to give me roughly 90. I can see that B and E is also going to equal 90 to get the angle measure for 180 because that's a triangle. So we can already assume that B and E are going to equal, even though it's not given. So let's read the information that's given right now. I'm given that tangent of A equals 50 divided by 7. So I'm going to draw a right triangle, right? We're given we're given that C and F are the right triangle. So I'm just going to write C because it corresponds to F. Actually, I'm going to draw F because that's what we're looking for. And remember, A equals D, so I can say that tangent of D is 50 divided by 7. So let's draw quickly the right triangle. So DEF, right? If D equals 50 divided by 7, that's going to be opposite over adjacent. So FE is going to equal 50, and then DF is going to equal 7. And we're looking for tangent of E. Tangent of E is going to be the opposite, so it's going to be 7, and the adjacent is going to be 50. Therefore, tangent of E equals 50. Sorry, it's going to equal 7 divided by 50, sorry. It's just the opposite. 7 divided by 50. And if you understand, like, all the angle measures correlate to each other, and as we can see, right, D and E, regardless of what, they're kind of the opposite, because remember, D corresponds to A, so tangent of D equals 50 divided by 7. You see what I mean? They're opposites. So if you're given tangent of D and we're looking for tangent of E, it's just going to be the opposite side lengths. Okay, this will be the last question for today. Triangle ABC above is a right triangle, and sine of B equals 5 divided by 13. What is the length of BC? Okay, so now that we know how SOHCAHTOA works, what it corresponds to, we can understand the following. So 13 is going to be my hypotenuse, and 5 is going to be my adjacent. Or opposite, sorry. So opposite over hypotenuse. Hypotenuse in ABC is going to equal 26. And my opposite in this case is going to be AC, right? Which is going to equal ultimately 5 divided by 13. So how can I look for AC? We can do one of two things. We can multiply 26 on both sides, or we can understand a concept. But let's multiply just to do the simple math. So AC is going to equal 5 multiplied by 26 divided by 13. And if you do that math with the calculator, because I can now do that mentally, you're going to get 10. So AC equals 10. But if we look at it, right, I can do 13 multiplied by 2. So if I do 5 multiplied by 2, I'm going to get 10 as well, right? So AC equals 10. But we're not looking for that. We're looking for BC. But how can I look for BC, right? Pythagorean theorem. Because we're given two side lengths. And to find BC, all I have to do is a squared plus b squared equals c squared. And I can look for my value of BC. And remember, we're given hypotenuse this time around, and hypotenuse is C. So we're not looking for C, we're looking for B. So I can do 10 squared plus b squared equals 26 squared, and I can look for my value of B. So ultimately, that's going to be 100 plus b squared equaling 26 squared is 676. If we subtract 100 on both sides, that's going to give me b squared equals 576. And if we do the square root on both sides, I'm going to get b equals the square root of 576. And if we plug that into a calculator, you're going to get 24. Therefore, b equals 24, and that is my answer. This is the last question for today. Thank you for watching.